Okay, so would using constants function headers contribute noise in the feature vector? Depending on how the compiler compiles the code, the function headers that would be used for calling a function can vary. Yes, and we tried doing it differently, where we completely ignored the function headers as is done in other approaches. And we actually found out that, the performance is worse. So we tried that, and it worked better when having the constants in. Have you considered approaches for leaf functions? The current approach is based on non-leaf function calls. If you developed a model for leaf functions where the features include the calls of the leaf function, how do you think that would perform? I think it would perform better, but one of the goals was to not go into CFG recovery or call graph recovery. So this is actually done by another approach, by ASM2VEC, where they go over where they sometimes decide to inline callies and so on. And it appears to work for them, but I wanted to see whether it's possible to kind of get the same effect without actually having to do the work of inlining it. How effective can Albert capture the structural features control flow from the binaries during code embeddings? Are these features important in detecting binary functional similarities? So structural features, in this case, we completely ignored the structural features. The features would be important, or using these features would most probably yield better results. But again, we tried to avoid using these features and just use the disassembly text as we exported it from Ghidra. Because, for example, T-Rex and Safe also just rely on exporting or only rely on the disassembly text and don't do control flow reconstruction. So in order for it to capture it, you would probably have to actually encode it, because we didn't observe that it has captured the structural features very well. Any other questions?
Thank you, Michael. I think I just have one clarification question. So how did you generate the synthetic data sets? Like, did you use C-Smith or C-Reduce for Tigris?
Yes, something like that. We used a simpler approach that is used in in papers that specifically focus on virtualized code deobfuscation, where they just used a grammar and generated functions based on this grammar. And we also had a very simple grammar with if expressions and arithmetic expressions to kind of model some kind of control flow. The issue was with C-Smith is that we, in order for the traces to work, we would actually need to cover the function. So we wanted to see if the traces work at all. So we didn't worry about the function coverage at all, and just generated functions in such a manner that we knew the input parameters that would yield us the largest possible trace or the largest possible coverage for this function.